And hello, I'm Josh, that's Chuck, Jerry's over there, and that means this is Stuff You Should Know. Maybe, or maybe it's stuff that you shouldn't know. Maybe it's stuff that we just don't care about. Why are you here? I ask myself that every week. Why the hell are you here? What do you get out of this? All right. I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. I don't know why, but I've got this weird feeling that I am supposed to be hearing you and I can't. And I know that the next 2 hours is going to be just me talking, but somehow it feels wrong. Hang on, I've got to pop out the chat and zoom it in so I can read it. Zoom, so that's Shift Command Plus. There we go. Got to figure out how to do it on this fancy keyboard. First squirrel, what's that thing behind you? Which thing? Do you mean, hang on, that is it that? Hang on, that's a water cannon. You've seen that. TTS for every message. Yep, that's right, Steve. Tassie Bob, the grey thing, yeah, that's the water cannon. Yes, yes. Which has been shown, maybe what you have seen in the past is a yellow water cannon. That's a really, really old one. Tabray's technical issues? I don't know. It looks okay. YouTube Studio is reporting a good connection, so I think we're all here. We're all okay. Unless there's something wrong in Estonia, Tabray's. What's going on in Estonia? Okay, got to quit that. I've got to open that. I'm getting to the chat list. And it still says upcoming. That is 8th of the 6th. Yeah, it's the right one. Yeah, the chat has not, like the TTS hasn't actually connected to the stream yet. It doesn't know. Oh, there it goes. Okay, here we go. So, good morning to Kim S, Tassie Bob, Amanda, Crispy and Pete, of course. Scott Miller, some call it fun, Tabray, Stephen George, Matt W, John Whips, Russell Rennie, Any Mules, Stephen W again, Tech Nebulous, Immy, Jax Tech. More will catch up, I'm sure. The TTS is just catching up with things. All right. Pete says, that specific part looks incredibly precise. What did you use to make it? What? Cable tie? Cable tie! Cable tie is here! TTS hasn't caught up with the fact that you're here yet. Stephen W says it's secretly at supercharger for Tom's car. It does look like that. Yeah, so hang on, which side? There. The little round thing there. Yeah, that is part of the end housing of the nozzle. And Zippy is here at the start, says Scott. Yeah, Zippy is here. Hang on. Oh, there we go. Yeah, the TTS is just taking a while. It just did a major update and it listed all of the names that I'd already said. Okay. Okay, I am in that mode now where I have been rushing. So far this morning, while I've been getting ready for the stream, I've had one client phone me twice trying to resolve an issue. And I had another client who was here up until 15 minutes ago and left just before I was, putting the mic on and things. And the result is I haven't drunk my coffee. The last hour and a bit, I have been rushing trying to get client stuff sorted, and getting into that mode where, you know, the more you rush, the more you screw things up. But the classic example is I was rushing, so I tried to grab the microphone off the shelf that is up beside me. It gets stored just to my right up on the shelf. And I grabbed it to get it out because I was in a hurry, but because I was rushing, I then knocked stuff and that then fell off the shelf. And then I had to pick all of that up and put it back. So yes, it's one of those things where you get to the point where the faster you try to go, the more you screw up and the slower you end up being. So I've got to get into that. I've got to slow down and get into that mode of slow is smooth, smooth is fast. There we go. Pete, what's your strategy for scaling up from prototypes to making more? Do you need a team of squirrels? Alistair is here too. And Simon. Good morning. And Sharky. There's... And Grant. That'd be a scurry of squirrels. All right, so let's have a look at I'm just having a look at dopamine. I'm looking for Project Dopamine. There we go. I'm looking for the spreadsheet because last night in Discord, Stephen said he really should have a screenshot of the Project Dopamine list. Let's do this. Maybe even more. Let's go 200%. 200. So, yeah, make area lighting, done, do it, done. ML PCB inspection, this is all future stuff. SourceBot Mark II, Stephen Steph in space. Inventory, make area benches, well done. I've already done, okay, I've done one. I need to do another one. Thermal camera, MOAC, Zero Stick, Front Garden, OpenKO. Oh, OpenKO is, I had this code open a couple of nights ago. Add incoming and whoop, outgoing. Ooh, good today, Johnny. 32 months. Thank you, Johnny. My hot Swedish friend coming through again. Incoming, outgoing messages via CAN bus. That is something that needs to be done to the firmware. Yes, I know, I'm reading this list backwards. I don't know why. It just happens this way. IoT AP. I don't know. Do I... This feels like... Alright. This feels like a project that needs to be moved to the bottom of the list because even though it's something that I really like, it's a fun thing to work on. Oops, why didn't that drag? It's a fun thing to work on. I don't have a burning need for it right now, and it's the scope of it is just a little bit too much for me to make progress on other things. And what is becoming more and more apparent to me is that I just need to say no to things and stop doing things. I want this project to come to fruition. My goal is, with Project Dopamine finished stuff, is to take these projects to completion, for some definition of completion, and have that feeling that yes, I can put that out of my mind. It's no longer something that is sitting, hanging over my head, waiting for me to get around to doing it, but that it's done and I can put it aside. But the problem is, in order to do that, I have to start being selective, and I have to start being brutal and just recognizing that I only have so much brain space and capability and time and money, and so I have to just cull some and push some down to the bottom and realize that there is a line here that I'm not going to get past. So for various reasons, the IoT access point kind of falls into that category. It's a big enough, complicated enough project that if I commit to following through on that now, it's going to push other things off. So I need to bite some things off the to-do list, off this project dopamine list, that are small enough that I can take them to completion and be totally done. And then it's, yes, and then I can move on to others. But it's that classic thing. Okay, so this is the ADHD brain thing to some extent, where the number of things on here is just too much, and I end up jumping around and I forget what, where am I going with this thought? Okay, what I need to do is move a blank line up here somewhere. I need a line where I say that below that line, I am just not going to get to it in the immediate future. And no matter how good my intentions are or how much I want to work on that, for example, Zero Stick is a project that I really desperately want to work on. That one is really cool. It's technically interesting. The scope of it is small enough that it can be taken through to completion, and it could be a very beneficial thing for many people. So I really want to work on that. But do I move that above the line at the expense of other things? Now, KiCad, I'm going to move that down below the line because, yeah, just because. Okay, OpenPNP cluster, I'm going to move that below the line, even though it is pretty much done, because what I need to do is be able to, I need to clear my mind to the point where I know there are things on the list below the line, but I don't need to think about them because I don't have room in my mind for them. I will just end up jumping around all over the place and not get to any of them. So there are important things that need to be up here, and Conveyor is very high. It's actually super high right now. Desktop CNC. Okay, this is another good one. So I have my, whatever it's called, the 6040 CNC machine, which is currently sitting on a trolley just outside in the loading dock area. And I want to convert that over to running Linux CNC, but I don't actually have a project that needs CNC right now, apart from a certain big project. Oh yeah, that's right, the truck curtain project. I can talk about that now. That needs CNC, but the CNC for that is being done by my friend Plasma Steve, and he is the CNC expert. He's got all the big machines, which means that if I do need something CNC'd, I have that option at his factory just down the road. So the need for doing that is actually pretty low. So I'm going to shove that down the list. Seal room compressed air dryer, like a proper dryer. I think I'm going to move that down below the line. I need to get this down to ideally 5 to 7 things. We're currently at 7. And things that matter. RJ45 breakout, produce updated design. I think I can shove that below the line as well. Now there are things that are either the criteria. Do you have a room for seals? Okay. Oh, other people who have joined. So Grant, I said hello to Grant. Also Jordan, Mitch is here. Johnny Bergdahl, I said hello to. David C. Only walruses. and whales and bowls of petunias. So, okay, criteria. What are the criteria? I should actually have criteria. What are the criteria for things getting up into the hot zone up here where I'm going to work on them? Okay. I think the criteria, very roughly speaking, should be there is a need for them. The scope is small enough that I can realistically take it to completion. What else? Well, I suppose that's the two things, isn't it? The two things. Now, or that they are close enough to completion that the final step, this kind of comes into the second point as well, that the final step is small enough that I can do it just to get it off the list entirely. Now, I think the air quality sensor falls into that category, which is why it's still there. There is no burning need for the air quality sensor project.
Some Call It Fun said, do you prioritize based on what only you can do vs what could be delegated, for example, world benches?
That is a good question. So what I can do versus what can be delegated. Yeah, welding the benches is not something that I'd thought of being delegatable. It is, of course. I could get someone else to weld them. But I want to do it myself. Because it's a fun thing, and because it is radically different to the stuff that I normally do day to day. It's more practice for me. Becoming better at welding is just something that I want to do. So I am absolutely certain that if I called Steve and said, Steve, any chance you could come over for like an hour and weld up the frame for those workbenches? He would say, no worries, I'll see you soon. But I don't want to put that on him, because he already does way too many things for people. and also because I want to do it myself. So, but your underlying question about, do I base it on what's delegatable? I never really think of things as being delegatable. I think because I'm in that mode of, I'm doing these things partly for fun and partly for myself. And there isn't a commercial aspect to this. Like the conveyors and the air quality sensor and Rack 32 and OpenKO, these aren't to make money. I lose money working on these things because it takes so much time, and I don't actually sell anything to any reasonable extent. Like Rack 32, how many of those have I sold? Like 15, 20, maybe? Something like that, total. For all the time that's been spent on that project, let's be generous and say I've sold 20 of them. And building them takes time and costs in parts, so there's not really much margin on them. Even though they're not a cheap board, they're still, it's not like I'm making, I'm not really making money on selling them. It's just because people want them that I make some. So I've got to stop, I've got to stop clicking the mouse. I just idly fidget with it and click on things while I'm talking. And now I'm fidgeting with the, I need a fidget spinner. Okay. I will play with the thing that Chris gave me as a Christmas present one year. So, yes, Mitch asked, are you doing this project because you need the thing or to get the hit from finishing something? It's a little of both. And things like Test-O-Matic, I want to do it because I get the hit from making it work. And I also need the thing. So the basis, I think, of Mitch's question is it a project or a tool? If it's a tool, then buy it. If it's a project, work on it. These kind of straddle that. The imperative for doing them is that I need the end result. And often that imperative, and then the correlated is not the correct term. The associated imperative to do it myself is because there isn't anything that quite does the job that I want done. So in the case of the conveyor, for example, I could go out and buy off-the-shelf conveyors. I could just order some from a Chinese supplier for a few $1,000s, but they wouldn't be quite what I want. They would do the job of being a conveyor, but they wouldn't have CAN bus integration. They wouldn't have the flexibility of the control system of what I'm trying to implement. So it's partly the dopamine of doing it. Now, I came across something interesting during the week. I'm going to chase a squirrel here. And I read it, and at the time thought, that feels so true. And then I don't know where I saw it, so I can't bring it back again. But it was a description of a feeling in neurodiverse brains, in some neurodiverse brains at least, and certainly in mine, of the feeling of the need to do something. And I'm going to explain this very badly. But, okay. I think it was Thursday night or Wednesday night. One of those evenings, doesn't matter. I ended up back at home really early, and I can't remember why. Something happened. Like I ended up, oh, that's right. I had been to see a client down in Dandenong, and I was back in the area at like 6:30, 7 o'clock. I was back in Bayswater, and I then just went home instead of staying on and working like I normally do. Like I'm usually here till probably 10 or 11, pretty much every day. And so I ended up going home, and I was at home at maybe, once again, it doesn't really matter that much. I was at home at probably like 6:30 or 7 o'clock at night, and I had this feeling that I couldn't sit still, and I had to get my laptop out to do something. I didn't even know what. It was just this pressure in my brain that I need to be doing something. I've got to do something. I can't just sit back and like watch TV or be passive. It's a feeling of needing to create something. And if I'm not creating something, then my brain kind of goes crazy. I need to be not just, what is it? Maybe it's problem solving. It's like this urge. Yeah, it's that thing of fiddling with stuff because I need to be doing something, but for my brain. And so I just had this, so I pulled out my laptop, I opened Fusion because I just had this urge. I've got to design something. I should be routing a PCB. I should be designing something in CAD. I need to be creating something. And it's almost like an addiction, like an urge.
Imogen Ann said, it's the ADHD restlessness.
Yes, that's right, Imi. And the way I saw it described on this post or whatever it was, it just put it very well. And it's an experience, it's a feeling that I've had for my whole life, this feeling that I've got to be doing something, but never really articulated it or never saw it explained in a very clear way before. Alistair says some ND brains need a fast idle to keep working. Yeah. Now there were some. I will get back to this list. I am going to have a quick look through the chat. Oh, Mitch says, I installed inventory for John. It's about 90% done, just needs some web server tweaking. Ooh, so that's a reference to this. Inventory, yeah, that would be quite useful. John said, did you swap the Cleanish room around? Yes, I did. Yes. I showed some pictures on Discord. I'm going to see if I can find, where are we? There. Yes, so we rotated the Cleanish room 180 degrees. At least some of it. We rotated the... I'm just looking back through pictures. Alright, so I need to open those two. And I need to open those two, I think. Yes, okay. Here we go. That's interesting. Just the way preview has tabbed this is interesting. If I do that, oh, that's cool. Then I can switch between the two views. All right, I'm going to bring it up on screen now. This is what it looked like up until Monday. And so this is what you'd be familiar with. We've got the bench on the input side here. This is feeding boards into the first pick and place machine. They travel away from us, and then down the back there you can see Sion's, come on, stupid touch interface that works half the time. There we go. No, not that one. Yeah, so this is, oh, that's the after shot. Silly thing. Okay, so this is the before shot, and that is the back side of the machines, exit coming out here, which then feeds into the oven. And this is the after shot, so this is after it's rotated. This end is where the boards get solder paste, and then they go into the machine. You can see the monitors are facing this way now. So this is the front of the machines. It's actually not that obvious. Like, that's backwards, that's forwards, backwards, forwards. Because they're just big white cubes with feeders hanging off two sides, when you rotate them 180 degrees, you almost can't tell. They look the same. That's the back of the machine, that's the front of the machine. And so what we've also done is move them a little bit closer to this back wall, and to open up the aisle here, the main aisle. So instead of having two aisles, like two working aisles, which were both narrow, we've now got a very narrow service aisle down the back and a wider working aisle at the front.
Pete said, as someone else pointed out earlier, you need a new live stream thumbnail made.
Yeah, I do. So, old, new. And if we switch over to that and that, so that's old with the back of the machines there, and that's new with the front of the machines. Don't know if you can tell. You can kind of tell. So the size of the aisle here, this is the old arrangement, was a little narrow, and then now it's a little bit wider. Not a lot. It's like 200, 300 mil wider. And I think I'm actually going to move these machines a little bit more that way towards the wall to make this back service aisle even tighter, reduce that space a bit more. So now the boards start from the far end, come through, come out here. This is the area I've been working on the conveyors, just in here. Right there. In fact, you can see the conveyor prototype sitting there on a laser cut frame, and then into the oven, and then the output side of the oven, if my stupid face wasn't in the way, would that there. Let's get rid of me. So the output side of the oven is here, and the boards come out and into this tray on the right hand side. So when you're standing in the front office looking at the glass wall, what you're looking at now is the output side of the oven, not the input side of the first machine.
How long until John walks right past the oven end to collect a finished board at the far end of the room?
I've already walked around the machines a couple of times the wrong way. So yeah, anyway, that is the update on rearranging that, and it's been a success. It's been very good. Okay, because I did not have a chance to fuel myself, I need to take a swig of the fine beverage now. Okay, that's a bit better. Yeah, okay, back to the chat. Oh, Scott says, I finished up a network job today that would have been a whole lot easier if I had my testers finished. Yeah, those testers, you are on a winner there, Scott. That is a really good project. Sorry, I'm just seeing messages from Pete. I'm going to have to come back to these messages. Yeah, Scott. So your project... Oh, I've got something else to show you as well in a moment. Some 3D printed stuff related to the conveyor. I will get to actual things soon. Stephen W. said AQS is 90% there. Yes. The air quality sensor, that's actually the reason that I've left it on the list here. All I need to do really for this, there are multiple things. I still need to get Austin on the stream. I haven't seen him in the chat, but I apologize to Austin for not following up on this. Yes, I need to get Austin on the stream to talk about the firmware for the AQS. I need to do the enclosure revision, and then I need to assemble some boards so that people can buy them if they want to. And I'll probably sell about 3 of those. Totally not worthwhile, but oh well, it's still an interesting project. So the reason that this is still staying up in the hot zone of attention is that it is so close that it's going to take Austin on a live stream plus about a day of work, and that will be done. So that'll be off the list. It's only a solid day of work away from being done, which would involve doing the enclosure revisions and assembling some boards, flashing and testing
Scott Miller
them.
said Rev 0.0.0 boards parts have all just started the shipping process, and I've already designed Rev 0.2.1.
Ooh, nice. Yeah, so that is on the list because it is so close, and then it can be marked off to the done section. Yeah, so Scott's project that I did, I mentioned it last week, and I showed some renders, is devices that you plug into Ethernet drops so that you can identify them at the other end. So if you've got a patch panel with a whole lot of Ethernet terminations on it, you plug one of his devices into a whole lot of ports, and then there are other little devices that you plug in at the far end of each of those drops. Each of the devices has an ID, and so you can come back and you can say, oh, that one is terminating at that location there. So it's a very cool thing. And yes, Scott, I really think you're on to a winner with that. Now, Pete has been putting messages in quotes, and I don't know if that's because he is quoting something or what it actually is. Pete, what are you smoking today? What is with these questions that are in quotes? So this one I'm just looking at right now is, how are you making sure everything actually works together reliably? Do they sing happy songs? I don't know what to make of that question. or some of your others. Eurovision fever, says Pete. Okay. Bruh. Oh, Kim S says, at times I find it hard to relax and turn off the brain. Always need to be experimenting, writing code, making boards. Got to learn and make cool new stuff. Yes. I need to... yes. Location of the oven is always a giveaway. Okay, all notifications. How did Tom react to the changes? Some call it fun. Okay, he likes it. Yes. I said last Sunday that what I would do is that I was coming around to the idea. The whole idea just came, it had never even crossed my mind. So it took me a while to get my head around it. And over the course of the stream, I came to like the idea. But I said that I wouldn't do it unless Tom agreed, because he's the one that runs the machines far more often than I do. He's running them 3, 4, 5 days a week, depending on what our production needs are.
I try to turn off my brain by opening the rye bottle, then end up designing weirder stuff.
So it's part of the creative process. And so I told him about it on Monday, and he really liked the idea. So we switched them around on the Monday, got it all rotated around, all hooked up, ran some boards, and the process seems fine. It definitely does still feel weird. It's taking a while for me to not feel like I'm doing things backwards. And I did actually walk to the wrong side of the machine a couple of times. So when I wanted to go to the control interface, I walked down the service aisle to the back of the machine, and I looked at it and went, no keyboard, no monitor. Walk back around to the other side of the machine, and there it was. But I'm used to it now. Now when I look at it, it looks normal. But it definitely did my brain in for a while. And yeah, Tom really likes it. It's definitely much more efficient. So as you're working between the machine and the bench, because typically what happens is that you will start something on the machine, it'll begin doing its job, and then you're doing something on the bench while the machine is running, and then something will happen, like a feeder will start screwing up, so you turn back to the machine to fix it, and then you turn back to the bench. Previously, with that sort of sequence, you would have to walk all the way around the room to the other side of the machine and then walk all the way back again to the bench. Now, you just turn around 180 degrees. You barely need to move. So control the machine from here, turn around and you're working on the bench, turn around and you're back at the machine controls again. So it's, yeah, I should have done it this way in the first place. The reason I didn't do it this way in the first place is that I was fixated on the reflow oven and the need for in future expanding through the end wall and seeing if I can convince Lachlan to give me some more space in his factory area. And so in my head, what I was thinking was, if I replace the reflow oven and I need to go through that wall, I don't want to have to rejig the entire line. I wanted the start of the line to be anchored, and for the end of the line where the oven is to be the part that extends or that gets rejiggered. But so as it stands now, to get a big reflow oven, I would need to move the pick and place machines back into like I'd need to push through that wall into Lachlan's area, and the machines would end up down having to be relocated. I would have to move everything to replace the oven. But yeah, but I figure that I can't afford to buy a new oven right now anyway, and if I do, it's inevitable that everything is I'm going to have to disconnect everything, move everything anyway. So I might as well make it effective in the meantime. Pete has sent another thing in quotes. What are you doing with, are you quoting yourself? I don't understand what's going on, Pete. So Pete's latest message is, how are you ensuring the systems are sturdy and won't just fall apart? Duct tape and hope? Yes. Wagon Load says, someone made a really nice workbench using UHMW butcher block, and I was wondering if that is ESD safe for electronics. When you say someone, you mean Adam Savage. I watched that same video. Yeah, former Mythbuster Adam Savage made a workbench, and he bought himself a 2.4 by 1.2 meter sheet of white ultra high molecular weight material to make the entire top surface out of it. So the entire top surface of the workbench is like a one of those white chopping boards, because he wanted to be able to cut on the surface and have a work surface that was good for the long term. And he also suspended it slightly on some spacers. I think he said quarter inch, but I don't understand what that is, so I'll say 6 millimeter. So he suspended it with a 6 millimeter gap above the main structure of the frame and put backlighting sheets. So the same backlighting LED sheets that he used behind splashbacks in kitchens. If you want like a glowing splashback, they make big sheets of LEDs for that purpose. And the so he put some of that under, it's approximately a quarter of the work surface at one end, so that when he turns it on, his workbench turns into a light table, so he can trace things, like put down, you know, a design and then put another piece of material over the top of it and trace it, because it's all backlit. Pretty cool project. Like most Adam Savage tested videos, worth the time. So go and check that out. Amanda has a signed photo by Adam Savage. Nice. Mitch says duct tape and hope has always worked for me. Yeah, hope is free. Duct tape is cheap. So they're good things to rely on. Pete, another quote. What's your process for finishing and putting together the final products? Do you give them a tiny hat? What are you doing, Pete? Okay, so also hello to Wagon Loads and VL Andrew. Muscle memory kicks in. All right, I'm going to try opening Fusion because I want to show you something. Show you this. You can't really see what this is on the tiny little thing in the corner of the screen, and it's all black, so I'm going to show you in Fusion. This just came off the printer this morning, and I haven't removed all the supports and things yet. I'll switch to the bench in a minute, and we can check it out. Ooh, I just got a message from Amanda. Let's see what that is while Fusion is opening. Where is this message? In the image, a house with a red car in the driveway. Okay, sorry, I was just looking at Peter Harrison's thing. Okay, what photo? Oh, it is a picture. Is it loading? Yes, there we go. Okay, cool. Hang on, I'm gonna, let's see if I can move this without doxing. So Amanda just sent this picture. So it's a picture of a picture of Adam holding a very big sword. And judging by the fact that he's got it resting across his shoulder with no padding or anything, I hazard a guess that that sword is not made of steel. It's made of something significantly lighter. Yeah, that looks like it was a while ago. That's a looking at the arrangement of his workshop area and the storage behind him, that is an old sort of thing. Yeah. Cool. Thanks, Amanda. Where are we? Where are we? Oh, Fusion has opened. All right, so I will open Conveyor and bring this up here. Conveyor frame. Frame. All right, so this is what I was doing yesterday. Because the conveyor project now is a very important thing for me. It's now that we've reversed the Cleanish room, we've got Sion's oven set up in place, and we are now running higher volumes of boards through. It is actually a serious thing now that I really need this conveyor project functional. So I need to build a few more of them. I'm going to open a couple of things here, and so there's that, this, front, there's this. I'm going to open, I'll open that, and that, and get rid of this so that I can go through the different things. All right, now, oh, actually, do I have a mock-up of the frame assembly? Do I have... Oh yeah, conveyor assembly 2. All right, this will be useful to explain what's going on, because you can see this quite clearly. Okay. Now, looking at it from the front. So this is what the conveyor looks like from the front, and I made the different parts different colors so that you can see where 3D printing ends and aluminium begins and vice versa. Now those linear rails are not the full length, they actually run from there all the way back up to there so that the back rail can move all the way along, and that is no longer done that way. So this is quite an old assembly. I don't know when this was last edited, but it was a long time ago. But it still serves to illustrate approximately what's going on. I start with this fixed square chassis, and it has these corner pieces. So this is made out of aluminium extrusion. It's 1 inch square extrusion. Yes. So 25.6 millimeter extrusion. 25.6? Something like that. Whatever a freedom unit is. And then there are plastic pieces that you hammer on. So you get corner pieces and then you hammer them together, and that forms the bottom square frame. So that square frame at the bottom is a fixed rectangle, and then everything else attaches to it. Cables go through it. So there are cables that go into the frame here, and then they pass around this corner all the way along the side, and then they come through this corner, and then they come up here into this mounting point. So this is the mount for the y-axis limit sensor for homing, and that's the clevis for mounting the idler pulley for the y-axis belt, etc. So anyway, you get the idea. This is pretty close to how the current conveyor works. If I went and grabbed the conveyor and you looked at it, you would see that this is what it is. Now, there are a couple of minor issues. One is, oh yeah, and the scale, some of these dimensions have changed slightly. This aluminium actually comes a little bit further out now. It doesn't finish inboard of the base frame. It now comes out just slightly past it. Or actually, I think it might end up flush with it. So the end of this bit of aluminium, this line right here, is now, and I think it might be 340 millimeters, I can't remember, ends up flush with the outer face of this frame. And that's dictated by the length of the GT2 timing belt that goes around it. So I'm in the situation now where I need to make more of these. Oh, and also we now have the board sensors attached. So there's a board sensor near the middle to detect the central position, and there's a board sensor at the exit and a board sensor at the entrance. And they mount on little brackets that go into this cavity and they protrude out so that the sensor is looking straight up towards where the PCB would be. All right, so that's the current state of play, approximately. And I need to make more, and I wanted to try to make something that was more integrated, and it would be simpler and more repeatable for me to assemble. This current arrangement, you can't see it here, but there are spacer blocks that go in between. There are all sorts of small parts. There are lots of holes that have to be drilled in order to locate things properly, and obviously the front and back frames, front and back rails have to be exactly parallel to each other. So it's kind of fiddly to put it all together, and I've been thinking through how to make a design that is more self-aligning and where the pieces are more integrated. And I will show you what I've been doing over the last couple of days. Front, back. Yeah, so this is a replacement piece for this corner piece. So that corner, I wonder if it's, hang on, where is that corner piece? Two-way right angle. What happens if I activate that? Oh yeah, there we go. Now you can see it. So that corner piece is a cube with two bits that stick off, and those bits that stick off you hammer inside the extrusion. And it actually deflects the extrusion slightly because it's a very tight fit into the extrusion. When you hammer this in, this top part of the extrusion ends up, like it starts flat, it's a very flat square extrusion, and then it starts to bow up a little bit in the middle because of the pressure. So this edge here, this top face, ends up with a very slight upward bow in it. This face ends up with a very slight outward bow. So the act of putting this extrusion in place, like hammering this together, and it's definitely a one-way thing. You cannot get this apart again afterwards without destroying it. So it's a one-way assembly process. You buy these plastic pieces, you cut the extrusion to the length you want, you hammer it together, and it's there forever. So I wanted to improve that slightly. So instead of buying these pieces, now the advantage of this is that you end up with a flush face. So the cube here that is the join has its face flush with the bottom face of the extrusion. And in a lot of situations, that's exactly what you want. If you want to make a frame, so I'm going to deactivate that now. Can I deactivate from here? Pin. Release with change order. Nope. No, I don't want to deactivate. Okay, I'm just going to activate that instead. All right, so yeah, you can see there that you get nice flush finishes, and a lot of the time that is definitely what you want. But in my particular case, I don't really care about that. So what I've done is designed my version of that corner coupling, but it fits on the outside of the extrusion instead of the inside. So the extrusion you cut to length and then you push it inside this coupling, with the result that the outside face of the extrusion is on this level. And that means that the corner coupling is actually a little bit thicker than the extrusion. It protrudes past it by a couple of millimeters. For me, that's fine. That's no problem at all. And it means that by tuning this...
Your face is flush.
Ah, thanks, Pete. Not as flush as your face. So you say such nice things. So by tuning the spacing on this, like the distance between these faces, it's possible to tune how tight that fit is. And hang on, I'm going to go and grab some stuff because I printed it. I will show you what's going on. What's going on? Overhead camera? Yes.
You didn't quote it.
I didn't quote what? Oh, he didn't quote it. No. He didn't quote it. So these are the couplings that I've been designing. So this is the simple, this will become progressively more complicated. This is the simplest case. It is a right angle coupling for 2 pieces. So if we've got this is just a short offcut of the extrusion that I was just using for measuring. So if we have a length of this, and it's a moderately tight fit, but if I get the angle right, I should be able to do it. Nope, I need to clean that one out more. One of these I had cleaned up because it needs to be printed with supports. There we go. So it slides inside, and it took a bit of force. I have no problem that is going to hold still.
Could put set screws in the plastic to ensure nothing moves.
Yeah, you could.
Provisions on the bottoms for feet.
Yes, so feet on the bottoms, exactly. But the thing is, I'm printing on this face, so I want that to be smooth. I could put a little recess in the bottom for a round foot or something to go into the recess. But for me, it doesn't actually matter if it raises it slightly, so I'm just going to put rubber feet stuck straight onto this surface here. Okay, so yes, you are right that what you could do is put a screw through here so that you could then make sure it doesn't come out. You could put glue in there if you wanted to make it permanent. But the way this is now, this is tight enough that it took a fair bit of force to get it in. That is not going to come out by itself. I can pull it off, but it takes effort. So I could, if I push that back together, it's tuned to the point where I'm confident that that is never going to vibrate apart. It's like a good solid joint. I could fix it with a screw if I wanted to be absolutely sure of that, but I don't think I need to. I can just push that together. I've pushed the frame together and it's going to stay. Now, that is a back corner. So that could be like a back left corner or a back right corner. And I've made it so that the cable can pass through the middle. You can see in there that it's just a tube. So I can run internal cabling between the 2 parts of the frame. Now, the next step is, so if that's the back right, that's the back left. I'll arrange them here. This is front right. That is front left. Now, what I did with the front ones is I integrated, because previously I had a spacer block in between the front rail and the front part of the frame. So the front rail would be elevated, and it has to be elevated because we need to allow for the thickness of the linear rail that supports the back part of the back cross piece. So what I did was I integrated the spacer, and you can see that what will happen in this case...
Cable tie said, heat, cool and expand. Contract cycles might see it working its way out over time.
Oh, that's a good point, Pete. So yeah, maybe I should put a screw or something in it. So I need a second piece of extrusion so I can demonstrate it. Do I have one handy? I'm going to have a quick look. I had a pile of miscellaneous bits of extrusion around here somewhere. Oh, down there on the floor. Okay. I'm going to have to go digging. Oh, here's a short piece. This will do nicely. It will serve to illustrate. Oh, and here's another piece with some fittings in it. Also very useful as a prop. Okay, so imagine this is the frame. That goes there. Oops. That bit goes on the other end of the frame, although it'll be slightly longer than this, of course. And then...
Scott Miller said, deburr and or chamfer the ends of the extrusion for easier insertion.
Yes, exactly. I need to do that. I need to just whisk it over with a file. And this then sits like that, with the correct spacing. So that's I think it's a 6mm spacing in between the frame and the front rail, which goes across the top. And it sits into the little channel, and it is a snug push fit. Now that is going to be bolted in, but I will get to that on the next little installment of this update. Okay, so these are printed. Now, unfortunately, on my printer, it takes about 8 hours to print this set of 4, which is painfully slow. That's very, very frustrating when I'm prototyping and I want to do some iterations, or if I want a couple of sets so that I can be ready to assemble some. An entire day of printing to make that. Yeah, it is. I think it's just under 8 hours, something like that, to run a print job. I've got a print job set up where it's got these units arranged, you know, like that or whatever. So it prints all 4 of them in one go, but that is 8 hours worth of printing. Then that accounts for the frame, for a conveyor, except there is a problem. The problem is with the PCB sensors. Maybe I do need to go and grab the other one. But this is the rail off one of my early prototypes.
3D printing as rapid prototyping. Lol.
Yeah.
Amanda Thompson said, time to get a new 3D printer.
Oh, believe me. Yes, I know. There is actually a Bamboo Labs X1C with AMS and all the options sitting in a box about 3 meters away from me, but it's not mine. A client bought it, he ordered it, and he ordered it at a time when so there was a big Jewish holiday last weekend. I'm not I don't actually know what the holiday specifically is for, but anyway, there was a fairly major Jewish holiday, and he ordered it a couple of weeks ago, and the estimated delivery date was right during that holiday. So he organized for the order to come here instead of to his factory. And so now I have this, there's now an X1C sitting there in its box, waiting to be collected. And I wish I could use it. Anyway, so this is how the top rail goes on. So yeah, you can just imagine that this is, oh, in fact, what I'll do is I'll put both sides of this on. Hopefully this is, I cleared out the supports enough. There we go. So that, imagine that's the front of the, that's the front of the frame. And then the front rail, this is actually a back rail, which is why it's got all these holes and things in it, and why it's got these things. But just imagine it's a front rail. And then the front rail sits into that like this. Very nice. Problem is, this bottom rail is not the correct length. If this was in the correct location, it would go, I think it's about there. Earlier I said that this ended flush with the frame. I made a mistake. It doesn't actually end flush with the frame. It protrudes out, I think, I'm trying to remember, I think it's about 16 or 18 millimeters. So it's actually slightly more than this. So it protrudes past the frame, and then the PCB sensor slots in underneath. And on the version that I did originally, which had the hammer-in inserts, that was fine because it could go into the gap. It was, the PCB sensor housing was actually designed to fit into the gap that used to exist here, but now there is no gap. Okay, so on a long conveyor where the frame protrudes way past this part of the mounting bracket, that's no problem because the PCB sensor can just be screwed on here, protrude out near the end, because it's always got to be right near the end of the rail. So it'd be screwed on underneath here exactly as it currently does, and there won't be any problem here. But in the case of the short conveyor, where it ends here, I somehow need to get the PCB sensor into this space. So one thing that I considered was just notching this out so that there was room then to put the housing through here for the PCB sensor. But then I thought, why not get fancy and do this? And because it's actually going to be kind of hard to see what's going on with this, where are my pliers? It's full of support material that needs to come out. I'm going to show you this in Fusion because the structure is moderately complicated. This was me having fun yesterday, and then I set this to printing overnight. Come on, come out. Oh, and there's a bit in here that has to come out. So as you can see, essentially what I've done is integrate the mount for the PCB sensor, which is the time of flight sensor, with the corner of the frame. So the whole thing becomes one big integrated piece with a cable channel through it for the IDC cable that goes to the sensor. And I'll pop that out. Yeah, I need to do a bit more cleanup, but that is basically it. So this is a front right. Will I fit that in? Maybe. Yeah, okay. So this is a front right piece of the frame. Get that off. Put that in there. Like that. And then the top rail sits in here, and the PCB sensor goes there with a little cable channel that goes down through it. So the whole corner is one integrated piece that incorporates the PCB sensor and all of the mechanicals for attaching the frame and the top rail as one unit. Now, what does that look like? It looks...
3D printing seems to be a good source of plastic dwarf.
Yeah, it does. Oh, John says you need to test it for him. Yeah. Yeah, Grant says, oh, Shavuot, June 1st to 3rd. Yeah, I think that was it. It was whatever it was a week ago, essentially. No, I do not want to update. Every single live stream I get this update. It times it for Sunday morning. Frame corner with current sensor. Okay, so this is that piece that we were just looking at. It's a lot easier to understand what's going on when it's grey though, rather than when it's black. So you can see that there is a mounting location here for the time of flight sensor PCB. And then, oh, Paul says, would this also work with the long conveyor? Yes, it would. I could have 5 board sensors on the long conveyor. I would just need more connections for it on the controller. I don't have enough connections at the moment.
Pete said, nice use of the specific machine for specific task. What settings are you using? Does it smell like cheese?
Same part, says Paul. Yes. So let's take a trip through here. We can fly through. Hey, what's that game from a few years ago where you were flying a spaceship?
Does Pete smell like cheese?
Descent, that's right. How many people here, yeah, does Pete smell like cheese? I don't know. How many people here remember the game Descent? That, I remember loving that game when it came, no, not when it came out, it was sometime after it came out. I ended up getting it. And yeah, it was one of the few visually really impressive games that would run on Mac, because I didn't have a Windows machine, so I couldn't run most games. But Descent ran on Mac, and it just looked incredible. And it was one of those, it was a 3D shooter where you are flying through enclosed spaces that are essentially like a maze and being attacked and having to destroy things. And so, yeah, David says, epic game, 6D movements. Yeah, Scott says, Descent was very dangerous if you were prone to vertigo. Yep. It's years since I've even thought about Descent. Now I want to play it. Yeah, so you're flying a ship through spaces that could twist and rotate. So you had no sense of up and down. Like you would end up going up into a passage and be flying vertically. But now is it vertical? Are you flying horizontal? Does it matter? If you barrel roll, so you're totally upside down, it just gave you a different perspective on things. So coming through this just reminds me of that. It just reminded me of Descent. So this is the shape. We have 2 bits of extrusion, three. One that goes into here and one that goes into here. And you can see I've put backstops in it. So the extrusion slides in and hits the backstop and only goes to that point. So if the extrusions are cut to the correct length and then you put them into the couplings and bed everything down, it'll end up with the correct dimensions. So we have 2 bits of extrusion that go in. Then the 3rd bit of extrusion, which is the front rail, sits on top. And you can see there's a small hole there through the body, and there is a big hole in the bottom that is aligned with it. The reason for that is to bolt the top rail on with a blind screw or a blind bolt. So the idea is there will be the extrusion sitting on top of this with a hole in the bottom of the extrusion, and the end of the extrusion will be just around here somewhere. So it's only like a small distance in from the end. So what I can then do is get something like, and this is a 3.4mm hole here, and this is I think a 10mm hole here. So what I can do is use something like an 8mm M3 bolt and pass it up through here. So the head will pass through this hole, and the head will end up under here with a hex driver going up through the hole. And then on the top side, you reach into the extrusion with the nut, and the nut goes on the inside of the extrusion. So the end result of all of that is that it will be totally concealed fastening. Hang on, I've got a cough. So totally concealed fastening, a bolt going up from the bottom from inside this, this printed part to a nut that is inside the extrusion. So when you're looking at the top rail, there will be no holes, no breaks or anything like that. It'll just be smooth. So it should look quite nice. So that will fix the top rail in place. Then the time of flight sensor PCB sits into this weird cavity, and I'll show you that in a second. And then the IDC cable that goes off from one edge of it goes down through this slot. Let's do our descent trip here. It goes in through this slot, and then we're now inside. Oop, we've lost all perspective. It comes in, whoop, through. This is the other side of that slot. Comes in there and then folds down, and I put an angle on this wall, partly so that when you push the IDC cable in, it'll hit this face and then be deflected sideways so that it will come out through here. And then the IDC cable runs through the inside of that extrusion, which is the front part of the frame, and then out of a hole of that extrusion into the controller. And the controller uses that to connect to the time of flight sensor. So the assembly here, oh, and the other thing, so this piece then sits on top of the time of flight sensor, and that is going to make sense in a minute. So this is an assembly, and you can see that there is this top piece. I'm going to turn off the cover. So you can see the time of flight sensor PCB just sits in that location. Cable soldered to it goes down through that hole, and then this cover goes on top, and then it's got two countersunk screws that go down into it, and the extrusion sits over the top of that tab. So hopefully that will end up being a very neat structure on the corner with everything integrated, mechanical and sensor and everything all inside this one thing. So, sorry, I'm pausing because I'm just hearing a car very slowly going past out the front. Yeah, that's the current plan. I haven't printed any of the top cover yet. So that is the top cover. And you can see that it has a little recess. That's to allow for the solder joints on the top of the PCB where the IDC cable comes through it, because the IDC cable solders from the bottom of the PCB, and then there are solder joints on the top of all of the bits of each of the 6 wires, and they form little humps on the top of the PCB. So the slot allows for those solder joints to have clearance. And that's the aperture where the time of flight sensor looks up towards the
Some
PCB.
Call It Fun said, does time of flight sensor work through plexiglass? Could cover just be solid to prevent debris from falling in?
That's an interesting idea. Yeah, it probably does. I don't know what wavelength the laser works at, but I'm pretty sure it would. Yeah, I don't know. I'm not sure if the time of flight sensor would be attenuated by the by plexiglass or something. So yeah, that could be a clear cover potentially. Oh well, something to experiment with. I also thought about doing these screws from the bottom. Oh, Tinker is sending me some pictures, which might be for showing on the stream. Yeah, so at the moment, 2 countersunk screws to hold that in. So if I turn these back on, this does kind of annoy me that there will be 2 screw heads visible here. But I keep telling myself that that's just me being OCD, because what I could do is make the top of this flush, have holes in this, and then have a hole from the bottom that passes all the way up. So have a large hole that goes up, say 2/3 of the distance, and then get smaller, so that a short screw could be put up through that hole, like with a Phillips head screwdriver or a hex head, and then the end of that thread would go into the cover. So I would need little holes in the cover that don't quite come through to the top, and then it could be screwed in from the bottom and held down. But that all just complicated things, so I figured this is functional, it works. A couple of I'll use black countersunk screws, which I have plenty of, into that, and this is going to be black plastic anyway, so it's kind of going to disappear. I need to stop being so obsessed with the aesthetics of it. Yeah, anyway, that was my little exercise yesterday afternoon, doing the this front corner piece of the frame. And that one that I just showed, ooh, Wagon Load says, lid slides on with a dovetail joint. Ooh. Jordan says, integrate clips. And Paul said, do you want to notch the edge of the cover to match the rail? I thought about making this more complicated, because what I could do is bring up, if I get rid of that and that again, what I could do is bring this in a little further and put a ridge along there.
Pete said, "What's the long-term goal for this? Are you aiming to build a sentient garden gnome?"
Yes, I am planning to build a sentient garden gnome. Yeah, so that this part, and remove that little notch there, and properties. No, that's properties of the material. Yeah, get rid of that. Make that a vertical end so that when this slides into place, it aligns with that profile. So include some of that profile on this cover. I could do that. Now, the other thing, of course, is that this could just continue all the way across, and then this cover could end right there. That would be the other way of doing it. Make that cover much simpler, so it wouldn't have this tab sticking out at all. It would just be a rectangle with two rounded corners, and this part would actually be fixed. It would be part of the main body. So I think that it would probably...
Scott Miller said, "Just extend the profile."
Yeah, that's right. So extend this profile. Imagine that was not there. This face here, extend it straight this way. Now where is that? Oh, I know why I can't edit that. It's because we're in the assembly right now. So if we're in here, what was that? Edit feature. That was a 1mm chamfer. And yeah, let's have a go at this right now. I feel like doing something constructive. All right, 1mm chamfer. Where is it in the timeline? Is that the chamfer? Edit feature. No. 1mm. Yes, 7 edges. All right, so that is those edges. Why are there 7? Why are there 7 edges? Okay, if I suppress that feature, suppress that. No, that's the wrong one. I want to unsuppress it. Why isn't it showing it in the timeline? I want to find that. Oh, there it is. Okay. Oh, it's all those edges. Do I want to... okay, let's see if I can just delete that without... I can. Nice. Okay. And then that... Oh, that is a... Yeah, because that's rounded around. Let's get rid of that and that. And maybe, can I get rid of that? Yes, that works. Okay, cool. I can do this. What we can do is go extrude and distance to object and bring it to here. And
3D CAD is a reliable source of brain damage.
It is a reliable source of brain damage. And then do OK. Then I want to get rid of that overhang. Not that it matters. I mean, that overhang could actually stay, except that it's going to be annoying from a printing point of view. So what I could do now is extrude all in that direction, cut, okay. So now we have a nice end. Yeah, that's kind of cool. Oh, before I save this, I just realized, no. I just realized why I did it the other way. Hang on, I'm gonna cough again. Okay. I wish I could do it like this, but I can't. And the reason that I can't is I need to be able to slide. Now, where's the assembly? Yes, you remember this piece right here? That piece? That needs to fit on. Now, can I make that work? Maybe I still could. Where is it? This one. Yeah, that one needs to slide on. And I think I need to remove that part of the extrusion back to about here. How far does it come off? All right, I'm going to go and grab the other bit of conveyor, the other prototype, because I don't have the full thing as an assembly, and I need to see what's going on. Well, maybe it would work. No, it is going to work. It is going to work as is. I will show you why. And the thing is that I could actually change the dimensions slightly on the horizontal rails. I'm going to have to move a whole bunch of things around here. This might be slightly out of focus. So this is the corner we're talking about. This is the front right corner. And what you can see here is the PCB sensor. If I angle that a bit, you'll get a better view. So that's the time of flight sensor.
Save as with a slightly increased rev room number.
Rev number? Oh, save as with a slightly increased rev number. Yeah, I see what you mean. Okay, so this distance here, if I grab myself one of my handy dandy little ruler or measuring devices, and from this face of the extrusion, the sensor is extending 18 millimeters past it, and that is flush with the end of this extrusion. So this extrusion comes 18 millimeters right there past that face, and then this has to clip into it. So this piece here goes into the end, and that needs to clear whatever else is going on under there, which is where our new little thingamajigamy is going. But that actually works because the 18 millimeters, this face here, is the location of the face on the new piece of the structure. So if we come back to this view, the extrusion comes past here. I wonder if I should square this off. No, I think I'll keep the angle because it looks cool. So this face here will end up approximately flush. In fact, I wonder if we can get a distance on that, even though they're offset. Can I do a distance from there to there? Yeah, 16 millimeters. And we've got 18 going to the end of the extrusion. So the extrusion is going to hang off the end of this by 2 millimeters, and then the cap will go into it. So that's perfect. That works really well. Very, very cool. In fact, I wonder if...
Scott Miller said, so it matches the end of the extrusion either way.
Yeah, yeah. So that is fine. That can stay like that. We can run this the whole way along. And then the cover that goes onto the time of flight sensor can be simpler. So I'm going to... All right, I am going to save this now. And I'm actually going to put a description in this version. I'm going to say extended top rail support, so that if I need to find it in my history in future, I can. So now, if I go into not that one, where's the assembly? This one. And I update this assembly, this should now change. Yep. And then if I turn back on the time of flight sensor, it's sitting there. And the problem now is going to be this, because it's got this tab that extends and I need to get rid of that tab. So back, front, sensor cover, this, I need to get rid of that tab. Now this particular piece of the design is kind of butchered from the original sensor housing. So that's why the timeline down here is really complicated. It's got lots of extra stuff in it because it's got things like the full size of the original sensor housing. All I did was make a copy of the project.
Scott Miller said, definitely making my case design look too simple.
So the simplest way for me to solve this, which is brutal but should be functional, is if I select that face and then I go extrude, extent to object, blah, cut, go. There we go. So that was a nasty, nasty way of doing it, but it does work. All right, so now we have a piece, and I'm going to say removed tab under top rail. Okay. So now if we come back to the assembly, we'll do an update here, pull in the components. So now we've got the time of flight sensor and its cover. And in fact, better still, what I'm going to do is come back to here. I'm going to change appearance so that we can see where everything is. We'll pick plastic. Oh, you can't quite see this, but oh well. Plastic, I'm going to make it not translucent. Why have I got such a, oh, opaque. Here we go. I'm going to make it glossy blue. There we go. Save that. And then when I update this, we'll get the material color coming through. And then when I turn on this, we'll be able to see where it fits. Why is there an interference right there? Ah, that's just because of my the two
Cable tie
bodies.
says that now also means you can access the TOF sensor without disassembling the whole joint.
That is absolutely correct, because it means that there is no tab that is trapped underneath the top rail. So I think this is a good improvement. Thank you very much for the suggestions. Once again showing, Wagon Load says, can you make Lego mounting pegs on the time of flight lid? Yeah, so you just push it down onto it rather than using screws. Maybe. Yeah. So I could have holes in the body, and the lid could just have little pegs that poke down into it. Like that sort of, is that the sort of thing that you had in mind? Quite possibly. So that it's just a press fit, you push it down and it stays in place. That would be cool. Yeah, oh, well, my interpretation was not literally following Lego dimensions or making it Lego compatible, more taking the inspiration.
Scott Miller said, wahahahaha, wagon loads.
Yeah. Yeah, more taking the inspiration from Lego that you can push things together and have them stay. Yes. Let's, that's going to take a little bit of tuning of the, yeah. What the hell? Let's do it. Let's go. Let's put a sketch on here and change view to, oh, come on camera, orthographic. I'm gonna put a circle on here. What size shall we make them? 4mm pegs.
Cable tie said, I like the screws. A clip-on lid feels cheap to me.
Yeah, I know what you mean, cable tie. That comment has thrown me. I'm not sure now whether I want to do this. Finish sketch. Okay, I'm going to, yeah, you're not actually going to see it. I don't know. Needs to have the Lego branding on the pegs. Let's just get rid of these features. Doink, doink, doink. Yeah, I know that was not very. I'm doing this in a kind of grungy way. I'm just treating this like clay and just grabbing, like deleting features instead of fixing them in the timeline and doing nasty things like that. So, hang on, capture position. Yeah, okay. How far down? Oi. Extrude. Oh, yeah, capture position. Let's go 3 millimeters. New body join. Why is this? Oh, okay. I suppose it does help if I read the.
Scott Miller said, where the screw is also holding the 2F board in place.
Yes. So. Sketches. Turn off that sketch. What is that error saying? Not that one. The other one that pops up when I go there is not visible. Bodies. Oh. What? Oh, okay. I'm in the wrong thing. Okay. Yep. All right. Forget that. I'm going to close this and not save it. It's because I've got a couple of different bodies in that.
Scott Miller said, you still need them then?
Yeah. But pushing, yes, I kind of do. Oh. Technically I don't, because the pegs could go through the holes in the PCB of the time of flight sensor. That's kind of what I was envisaging. But, okay, for now I'm going to not do it. I'm going to leave it as, where am I? Corner sensor cover. There we go. So back into this without the change. So now, where's the assembly? The assembly, it is up to date. You still need them. Dovetail slide on. Yeah, stick with the screws, stick with the screws. Yeah, okay. I'm going to follow cable ties feeling on this and stick with the screws. 2 screws, they go down from the cover.
Stick with the screws,
Yep.
Stick with the screws, stick with the screws.
Yep, they go through the cover. They then go through the holes in the PCB and then go into, they bite into the body. So they squeeze everything together. They squeeze the top cover down, they hold the time of flight sensor in place, and everything is happy. Yeah, I'm going to stick with that.
Cable tie said, wise counsel, I call it.
Yep. So this is, oops, wrong thing. So this is where we are ending up. Yeah, I like it. I just wish I had a faster printer. Maybe an X1C. I actually have one in my shopping cart. Bamboo. My my notifications are going a bit nuts. Oh, that's a WhatsApp chat about organising a scuba diving trip. So my shopping cart right now is this. I'm not actually going to check out. Some PLA, some reels, and a combo X1C with the AMS and the hub. But whoop, this is what
Scott Miller said, could use a CNC mill to make it from aluminium.
I could if I wanted it to be $1 million. Yeah, so
Outside the box said, keeping it in the shopping cart is artificially holding the price up.
Artificially holding the price up? What do you mean by that? How is it artificially holding the price up? Winter sale, winter sale. Yeah, I probably could. Now, the thing is that if I went for something like a P1P or a P1S, it is sufficiently cheaper that I could probably bring myself to actually check out. So something like, yeah, $1,500 for the P1S with the AMS2 Pro. I could probably bring myself to do that. But what I have in mind is that I want to try something I've wanted to try for a while, and I haven't been able to with my current printer, like that one, the Prusa that you can just see over my head there.
Scott Miller said, I keep looking at my excuses for 3D design thinking I need a little 5-axis desktop mill. Pete said, that specific part looks incredibly precise. What did you use to make it a unicorn horn? Outside the box said, you're expressing interest. If you didn't, they'd have to drop the price. Amanda Thompson said, just buy it. The time you will save will be worth it.
Yeah. All good points. All good points. I should. But I've got to watch the bank balance. Because, yes, anyway. Reasons. I actually don't have access to that much money. Because it all goes into all of my income goes into a trust account, and does not come to me. It goes towards paying for the house that I no longer live in and all sorts of other things. But anyway, let's not get into that. So, yeah, well, this has been an extended tour through the strange shapes of my brain and what I was doing yesterday. It started off with designing the corner piece and then extending the corner piece to add the support, and then thinking, I need to integrate the sensor, and it all just grew from there. So I just kept adding and extending and making it more complicated. Now, there were some messages.
Scott Miller said, for a break from the complexity, take a look at the Pix IDMD to you.
Yes, I was just going to say.
Said, Britney Spears' dad gets it and doles it out to him only when he sees fit.
Yeah, that's right. There is a conservancy looking after me. Take a look at the pic. So Scott DM'd me some stuff. Where is Discord? Hang on. I'm going to switch to this view. Stereo. And get rid of, there's some weirdness in the scripts that handle the view changes in, there's Discord? No, Discord is starting. Yeah, that handle the view changes when I switch camera views and things, and it gets confused about whether the picture-in-picture down in the corner is meant to be turned on. So I need to figure that out. That's since I switched from doing the live streams 100% from the Mac Mini with the 8M instead of having the laptop off to the side that was also doing stuff. So here we go. Looking at Tinker's messages. I'm gonna Open in browser. Yes. I'm just going to pre-open a bunch of these things. Open in browser. And open. Open. Yeah, okay. Here we go. I'll bring it back to this view. So these are the things that Tinker just sent me. Oh, I just grabbed the space mouse to try to spin the view. No, it doesn't work that way when it's a screenshot. So this is part of the housing that Tinker is designing for the Ethernet. What do you call this thing, Tinker? Does this project have a name? Rack unit bot. Okay, rack unit mid case, rack unit bot. Oh, that'll be bottom case, rack unit top case. It needs something more than rack unit. It needs some kind of a funky name. So, so yeah, so this is the housing that Scott, oh, bunny gear.
Outside the box said, I was busy pinching with my fingers on the screen.
Yeah,
Scott Miller said,
Zoom.
So far, been calling it bunny gear.
Bunny gear, okay, that's cool, kind of cool. I like the bunny gear thing. So this is one of the little bunny gear devices. You can see the RJ45 socket in it. That looks like access for a screen. And these are different parts of the case. And case top. Have you printed any of these cases yet, Scott? It was a rabbit hole project. All right, that's the reason for the name, bunny gear. Yeah, that's cool. Yeah, different parts of the case. So top, bottom, and mid. Those are the three parts. So it's a 3-layer sandwich. And when it's fully assembled, it looks like that. You can see the 3 layers of the sandwich with the device in the middle, all screwed together. Screen there, RJ45 socket there, or 8P8C if you want to be technically correct. An 8P8C modular socket. It's been a while, but back when I used to always refer to them as RJ45 sockets, I would have people telling me off, just most times. It's not technically an RJ45 socket, it's called an 8P8C modular socket. Yep, so you can see the 8P8C modular socket there. Scott says, Austin has been giving me grief over my designs. Why? Oh, Scott says I don't have a 3D printer. Well, if you like, you can send me STLs or something and I will print pieces and do some test, some test fits for you. That'd be cool. So yeah, feel free to DM me STLs. Ooh, and here's another picture. I'm going to go open in browser. Ba-doom, there we go. So you've got the little devices that go at the ends of the drops there. And then you've got the device here with the screen that you plug into the patch panel. And reports back what device it sees at the far end of that particular drop. Nice. Yeah, so Scott, I can print some stuff and send you, just make sure things fit, do some test fits. I don't have the PCBs obviously, but I could print the plastic parts and see if they physically fit together and send you photos or whatever, post them to you. Could be cool if it could display the LLDP info. Okay, whatever that is. Okay, now I am gonna not have this live stream go very long because of some drama. Drama time. Okay, this is the drama. I've got to pause and think about whether I should actually reveal this, but I don't think I'm revealing anything too personal. The thing is, if this was just related to me, I would tell you, but it's something involving my mum and a bad situation that she's in right now. I think it's okay to tell you. So I don't think she would mind. So in my mum's house, there are 2 self-contained flats, and one of them has a tenant in it, and the other one, she's looking for a tenant, and so she's been advertising for a tenant. And yesterday there was going to be someone coming up to do an inspection to see if he wanted to move in. After talking to him on the phone, she had a bad feeling, spidey senses tingling, and she decided she did not want to have him come and inspect the flat. Like, she basically decided to reject him as a tenant before he even came. So she sent him a message cancelling the inspection. He then started sending her highly abusive messages, including saying that now she owes him $400 for his wasted time and travel arrangements, because he had been making arrangements and paid for taxis or something to come and visit to do the inspection. So because she cancelled the inspection, she's got to pay him $400. And he just became more and more abusive through the afternoon yesterday, and said he was going to come up and take $400 from her. And then he said he was going to come up today and take $600 because he wanted the $400 to cover his wasted time and travel from yesterday, plus it would be another $200 because he'd have to make the trip to come and get the $400. And so, yeah, and Mum has got abusive voicemails and text messages and things from him. And so he's been told not to come. He's been told basically, stay away, do not come. But there is a possibility that an unbalanced individual is going to turn up at her house this afternoon demanding money. So I am, after this, yeah, plenty of proof to send to police. Yeah, so she was going to contact the police and submit a report saying that she was being
Scott
threatened.
Miller said, sounds like a grifter.
Yeah, more than that, it's someone who is seriously mentally unstable, just based on the communications that she's had with him so far. This is someone that is
Amanda Thompson
unbalanced.
said, have you reported it to the police?
She was going to. Yeah. And so I'm going up there this afternoon to just hang out at her place for the afternoon in case a seriously unhinged person arrives unexpectedly in a taxi demanding $600. Yeah, I'll be ready for it. He may not turn up, but he may, and I don't want her to be there and put in that position of having to deal with that. Scott says, say, don't get yourself arrested. No, I won't.
Scott Miller said, don't get yourself arrested.
No. I would use only reasonable and proportional force. But yes, dealing with me will be a lot harder for him than dealing with my mum. So, yeah. Jack Seck said, call the police non-emergency line and potentially have the mental health services on standby. Yeah, so we're organising all of that sort of thing. It may be that we don't hear from him ever again, but he might turn up. Anyway, the point of all of that is I am not going to run overtime today. After this stream, I am going to finish up here and head to her place to hang out for the afternoon with my laptop, because then I can do some...
Pete said that enclosure design is clever. How are you managing the internal wiring? A tiny spaghetti monster.
Pete, your comments today are so funny. Like, Where are we? Let's get back to Fusion. Yeah, running, it did. I have thought this through. Now, what I need to do is, if the cover is off, no, not that. If I take the cover off, what I need to do is solder the IDC cable onto the time of flight sensor. Now, one thing that would be cool would be if I mounted a socket in here. So the time of flight sensor could have pins on it and just be plugged in, and then it could be removed. That would be really nice. But I'm not sure if I've got the clearance, because I've got to allow for, you see this space here? The time of flight sensor overlaps the extrusion that runs in through this point. I don't have that much thickness to deal with. So, although if I moved it 2 more millimeters, no, it still wouldn't be enough. So, yeah, so my plan is IDC cable, solder it onto this end of the time of flight sensor, then feed the IDC cable down through the slot, and it would then hit that face and be deflected sideways, and I would then end up with, and then screw all of this together. So I put the cover on, screw it closed. I would end up with a tail of the IDC cable hanging out here, and then the extrusion could be pushed on over the cable with the cable coming out a hole in the extrusion. Then crimp the IDC connector on the other end. So once that's been done, it will no longer be possible. Basically everything will be captured by the cable. And I don't really see a way around that. It's either going to be captured at this end, it's going to be captured at this end by the sensor, and it's going to be captured at the other end by the IDC plug. So I don't, and what you might have noticed here is that the holes on this don't quite line up. Like you can see the hole on here is matched, the hole at this end is not matched. That's actually an error in the model for the time of flight sensor. It's not quite accurate. And if I put the cover on, you can see that the sensor thing doesn't quite align with the aperture, but in reality, it fits. So yeah, just in case anybody was looking at that and going, oh, hang on, you screwed up there. Yeah, it's just that placeholder model is not quite an accurate representation. It's just it's close enough. So, yeah, I don't see a neat way around that. Cabling this is a bit of a pain because of all of the cable that has to run through the inside of the frame, and including to the back sensor, like the sensor that goes, where are we? Where's the conveyor assembly? Yeah, so we've got cables that run all the way down through the side channel and come out there. We've got, there's actually a drag chain that goes along the side here, and then cables that go up inside this back rail and then run to the motor on that back rail, because we need to be able to run the back conveyor. Ooh, Scott has just sent me another, hang on, I'm going to open that, open in browser, yep. So this is a view with one of the covers removed. You can see a couple of coin cell batteries there, and you can see the pins there for the AP8C socket. Yeah, nice. Looks like a diode there or something, not quite sure. Or is it a switch? Can't quite tell from the render. Yeah, so managing the cabling on this is kind of annoying. A lot of it is pre-cutting cable, feeding it through while the chassis is sitting there, not in its final position. So with the extrusion sitting in their correct relative positions on the bench, but not all fully closed up yet, so that I can push cables through, because I need to be able to push a cable from a hole that you can't see it here on the render, but there's a hole here in this front extrusion where the cable comes out, goes inside there, down here, around that corner, all the way down here, around that corner, and then up through another hole. And to get that cable through there, you've got to do it a bit at a time and feed it all the way through before the frame is fully pushed together. So you end up with a thing where there's cable running through like loose bits of extrusion and corner couplings and things. And
Scott
then
Miller
you
said,
push them
"Time
together.
to go defend mum."
Yeah, that's right, Scott. Cool. So, I'm very happy with that little change to this. That's a cool thing. So I need to print one for the other side and also print one with this updated design and print the cover that goes onto it. So, and also need to update this corner bracket and add the screw hole onto it. Yeah, so there are some changes to do. In fact, I will take my laptop with me and I'll make those changes while I'm relaxing at Mum's place, spending the afternoon.
Pete said, "Go home, John."
Hoping that nothing happens. Yep, I am closing everything up, quitting out of that, quitting out of Fusion, and I'm going to quit out of Discord, and I am going to continue resisting the urge to hit checkout on that, and stuff. Okay. Controller.
Pete said, "Everyone, dislike, unsubscribe, and close YouTube."
Yep, there's a there is a big thing. The controller, that is something that
Scott Miller said,
that's a
"Next
major
week,
thing.
You can show us the corner brackets with internal curves to allow just pushing cables through."
Yes, yes, I will work on that. Okay, cool. Well, I'm going to go and put on about 17 very warm jackets and maybe some like heated electric socks and go up to my mum's place and hang out there for a while. So, thank you very much for coming to my TED Talk and hanging out with me on a Sunday morning. I hope you have a fantastic week this coming week. And there is a cool project that I've been working on over the last couple of weeks. Client project. Haven't been able to tell you about it. I want to tell you about it. I will be able to, but not yet. I'm hoping that next Sunday I will be able to reveal that. But for now, it is still a secret squirrel project. It's been a really fun one. Really cool. Yeah, so where's this button? There it is. All right, thanks. See ya.